Uh, okay. Last week I gave a presentation, and there was a lot of conversation about that. Um, and I don't know that we answered all the questions or discussed all the issues. Does anybody have anything they'd like to talk about before I kind of give a review?
Proceed.
No, huh?
Proceed.
Didn't hear you.
I
No,
think you
my
just said we can see your slides. Did you say that?
Oh, okay.
proceed. I'm
Okay,
sorry
just
for
as a reminder,
interrupting.
this is what I talked about. What is space? I tried to touch on a lot of different topics. I talked about what space is, um, and a lot of issues. There's a lot of issues when you're starting to talk about space, properties of space. Okay, this is kind of you know, what is it? What are its characteristics? Active or passive? And then we got to Rick made a comment about, he said that space is cold, okay, as a
Well, I
property of
would say
space.
I would amend that saying space is a lack of temperature. Let's put it that way.
Well, yeah, okay. Well, you might want to say that. I, to me, so does space have a temperature? So now this gets you into a problem of what do you mean by temperature? If space is an ether, okay, is some kind of an ether in the space, if it has this material property of what a lot of people are talking about ether, and there's different ether theories, then if it has a temperature of 2.7 degrees K, isn't that some evidence that ether exists? Right? Wouldn't you think so? So if it's full space, which means that it's a something, not a nothing, then the fact that it has a temperature would be a property of space. It's got a temperature.
Yeah, but are we talking about the same thing when we talk about a microwave temperature as opposed to a heat scale here on the planet? I think that's two different things.
Mm,
Radiative heat.
Or as
It's
opposed to a
temperature, sorry.
convective temperature?
No,
Yeah,
temperature is temperature.
exactly.
Don't say so.
well, it seems to me that they've determined that space has a temperature of 2.7 degrees K. That's a proven observational fact.
French laureate in physics, we have two of them.
So they claim that this 2.7 K temperature that they've detected, black body temperature, it's a black body temperature. They claim that that's evidence for a explosive Big Bang. But is that really the
How is
case?
that evidence?
Well, I said they claim that it's evidence.
Yeah, so is it a relevant question to raise as to why they claim that?
Well, I think that's the reason I'm bringing up this discussion. I mean, to me, my view about this, I found this whole discussion claim to be peculiar and ununderstandable. I don't understand it. Does that make sense to you?
Yeah, and if I understand your slide, you're saying the Big Bang radiation and universe expansion are um, uh, are those hypotheses falsifiable in the last bullet point? And I,
Correct.
and I think you're
How can you establish? I mean, I personally think that there may be an alternative of saying, well, the universe has a temperature, 2.7 K. That's the temperature of the universe.
okay.
Isn't that a possibility?
Yes, I would say that if what we call partial vacuum is really full of energy quanta, such as I described in binary mechanics, they would have a measurable amount of energy, which would be reflected as a temperature above 0 K.
It's an interesting way of looking at it, but I mean, temperature is meant to be an intensive parameter, so that for any smallest area of space, you can still define the temperature. And if you got a temperature sensing device and shielded it from all radiation and just immersed it in a few cubic centimeters of space, would you get this 2.7 Kelvin? You probably wouldn't. If you did, I think you could argue that that is the temperature of space.
I
How
would
would
be
you,
surprised if you did.
Yeah, same here.
what do you mean?
So I'm assuming that, you know, they use the words themselves, background radiation. It's the radiation which is being received from all parts of the distant universe on a particular uh, measuring device at a point. But it's microwave background radiation. Now, if you had a device which could shield itself from all radiation reception. Well, if you have a thermometer which is shielded from all radiation, but is put into a hot fluid, it'll give you the convective temperature because there are molecules bouncing against it, you know, and that's transferred to temperature. If it's an interesting concept, I have to think of what you've just said. But
You would
if
end up
this is
with
an
0
etheric
Kelvin.
temperature, an
Ian,
etheric,
you would end
yeah.
up with 0 Kelvin if you did that.
Well, we don't know. I mean, yeah, if the ether is composed of particles, well, are they moving around so that you would have a non-zero absolute temperature? You'd have
Well,
slightly above that.
microwave radiation is radiation, and if you say that you shield this thermometer from all radiation, you would end up with a temperature reading of 0 Kelvin.
Or
That's based on,
I prefer
excuse
to say
me,
it's
hold on.
undefined.
Hold on. I personally think that no such device is possible. Okay. I don't think such a device is I don't think you can put a temperature in space someplace and then shield it and say that would measure zero. I claim that's impossible because whatever the device is that it's going to absorb and re-radiate energy. Okay, so it's gonna get energy from the microwave background and starlight and whatever energy is out there, and it's going to heat up as a result of that to 2.7 K, we would think, in an equilibrium situation. So I don't think you can shield. How are we going to shield it from all this radiation? The shielding is going to get hot.
Presumably ordinary thermometers have a silver bulb to shield the sensor as far as possible from radiation effects, because you're measuring a convective temperature. You're measuring the flow of the fluid in proximity to the bulb. So if that's so,
Well,
I just
now we're
thought of that now,
talking
but if
about.
that's so,
Here's my
yeah,
point I'm making in
yeah.
this. It depends on what you mean by temperature and how you measure it. So we're talking about the measurement procedure, right?
Yes, but
Temperature, guys.
we're trying
What
to
is the
distinguish between
temperature?
convective and
Give a
radiative.
definition of temperature.
Well, it's in order when you're talking about this, you have to have a procedure to measure it. Okay,
Yes.
and the definition is related to the procedure to measure it. So but what the cosmologists have done is they've essentially said their procedure is looking at the spectrum of the microwave background radiation and comparing that to a black body, and they say it's 2.7 degrees K, and that's the temperature based on that. So they've specified a procedure for determining the temperature of the cosmic microwave background radiation, but they don't really infer that as being the temperature of the universe. They say that's the result of Big Bang black body radiation.
Well, I think we all counter that. That's just ad hoc. propping up of their doctrines. But I mean, if you had a block of ice, that is subject to this 2.7 Kelvin temperature radiation effect. However, the block of ice is still at 0 degrees Celsius. You put a thermometer in there and you find it's 0 degrees Celsius. Just because it's impeded
Block
upon
has
by
its
radiation.
temperature 2.7 in any case from outside. How you can block thermometer inside if you have your shield with temperature 2.7 K? Guys, where is your logic? You cannot block anything against temperature. You will put some device, immediately it will be heated to 2.7 K, and it will irradiate this new wavelength, microwave wavelength, and they will heat up any thermometer inside. Guys, we're talking about so obvious issues. Give the definition of temperature and how you want to measure it. It's a very important point of Harry. I absolutely agree with him that you can measure by black body radiation. There is some theory, there are some numbers. You have a spectrum, and you can calculate based on spectrum. And what is important, it's not close. It's exactly black body radiation with a very good accuracy. It was specified, defined this temperature with accuracy 3 digits after the comma. Why? Because this was very ideal black body spectrum of this microwave background radiation. That's why it's a very good instrument for all of us to measure temperature based on black body radiation spectrum.
Is the 2.7 K the peak of that spectrum?
No, it's the
It's a
fit
wrong,
of the
wrong
spectrum.
question. You don't know about temperature. Man, I'm talking about the whole spectrum will show 2.7 K. The maximum is some wavelengths. It's not temperature. Guys,
Right.
we don't know anything about black body radiation if you're asking these questions.
Let me try to answer what you said, Jim. It's a fit to the spectrum of the black body.
That's
They
it.
fit, they have an ideal computer fit to the ideal black body temperature distribution, and they make a best fit estimate to that.
So
that make sense?
Yes. So it's not just the peak. It's the whole curve.
Presumably, if they're doing it correctly, yes.
The whole curve. You're absolutely right. The whole curve. Guys, let me give you the definition of black body radiation. What does that mean, black body radiation? Do you know that the photons, they don't interact with each other? You can have some equilibrium between them, only you have matter. It must be interaction of these photons with some real matter, and it should be some thermal equilibrium. Temperature of radiation, it's exactly equal to the temperature of the matter in contact with this radiation. You see, there is no black body radiation if you don't have matter around. You have no interaction with this. Bullshit from Big Bang model. You generated 13, 14 billion years ago these photons. They are going to us this 14 billion years, and each of these photons, they have a wavelength. And when they are going to us, the space is expanded, extracted, whatever, it doesn't matter. And wavelengths following this, increase of the space, this expansion of it. It's so much bullshit. I cannot believe, and this is one of the best confirmation of the Big Bang model. Wavelengths of
Okay,
each
hold
photon
on.
spread
Hold on.
during. I'm sorry.
Hold on, Vladimir. Did you understand what he was saying there? It was kind of difficult to follow what he was saying. Did you kind of understand what he was saying, Jim?
What Vladimir was saying.
Yes. Did you follow what he was saying? No,
Sorry,
no
guys.
questions?
What?
Huh?
Well, if that's directed into my corner, I think there's information that photons can interact to produce electrons. And this has been demonstrated in the laboratory, supposedly.
Okay, that's a different subject. What he's talking about is how the black body radiation law is determined. How they
Right, he was
derive
giving a
it.
description of black body radiation.
Correct. And
Definition
what
of
it
black body
assumes
radiation.
is,
Guys, go to textbook and you will see this definition. It's not mine. It's 100 years ago, at least 120 years, 25 years ago, it was done, this definition. What does it mean, black body radiation? It must be thermal equilibrium with some kind of matter. Inside of this radiation, outside of this radiation, but there is only one way to have this curve, the whole curve, with thermal equilibrium with some kind of matter. You must have anything real. And in my model, it's intergalactic plasma. You have your electrons, you have your protons, and these photons, they interact with electrons of intergalactic plasma. But if there is no intergalactic plasma, there is nobody to interact. Will spread wavelengths of each photon, and that's it, simple like this. And
Well,
this is
the universe is 99.9% plasma. That's a fact. You're
man,
correct.
don't go to your intergalactic plasma to whatever. Let's concentrate on a black body radiation.
No, I was
Give
telling
your
you that you
definition
were
of black
right.
body radiation.
I was telling
Based
you
on
you're
your
right.
99% of intergalactic plasma, whatever you specified, let's put something around thermometer and we will have 0 degrees Kelvin. How it could be? What is kind of the proposal you have right now? If you don't
Well,
know what does it
whatever
mean
about the
black body radiation?
definitions and the process, I think the common narrative nowadays is that if there were no background radiation, which they say is a remnant of the Big Bang, the temperature of outer space would be absolute zero. But since it's 2.7 Kelvin, and that was a figure which we looked at and we got very close to that, that proves our case. Now, actually, that's incorrect because the first calculations of what any remnant radiation from the Big Bang would be is something like 50 Kelvin, 25 times the value they got now. So what we're getting now is we're getting a value, and they're actually twisting it into acceptance of the Big Bang Theory, which actually the Big Bang Theory didn't actually predict.
yes, that's
Comment,
they've
some
changed the value that to make the value agree with the observations. Now, one of the reasons I bring this topic up is because I read a paper by George Gamow, one of his original papers. And in his original paper, he makes an assumption about the temperature of the universe. And he estimates it something like 7K. So his
5K. The best his evaluation was 5K, not 50, not 7.5. I know the
well,
history of
let
gamma very well.
let me explain. I haven't. It's my memory about this paper is not very good, but my understanding is that he assumed that there was a temperature of the universe to which he added the temperature of the Big Bang radiation. And when I read that, I thought to myself, that's weird. Why is he assuming the universe has a temperature? But since then, they just ignored this idea of the universe having a temperature and say, well, it's all just due to the Big Bang. And it's always been a puzzle to me as to why they neglect. Okay, I'm sorry. I should have been paying attention to the time. I got cut off. So my point I'm making is that this paper that I read by Gamow, I've never been able to find it again. It was many years ago. I'm not sure where it was published, but it struck me that in the paper, when he calculated what the temperature should be that should be measured, he included a temperature of the universe as well as temperature of Big Bang radiation. And I've never seen where anybody, so there's an assumption in there that he made when Gamow made this first estimate. He assumed that there was a temperature to the universe, presumably due to things like plasma and cosmic gas and that sort of thing. He doesn't really define it. He just gives a number. He just puts a number in there. So my point I'm making here about this is why are they neglecting the idea that the universe may have a temperature due to the material that exists in it? And in Vadimir's world universe model, he assumes he has a cosmic medium, and I'm going under the conclusion that he thinks that his cosmic medium has a temperature.
Yes. Let me one more time to tell you about the definition of black body radiation. If you have your radiation with 2.7 degrees K, it should be thermoequilibrium with some matter at the same temperature. In my
Right.
model, it's intergalactic plasma. It's filling out the whole space, the whole world. And that's why you have witness of this temperature of the whole universe. In your words, in my words, it's world. Based on thermoequilibrium between this radiation and the matter, intergalactic plasma. Without intergalactic plasma, there is no temperature. There is no, it should be some interaction of these photons with some
Harry,
body.
Harry, is the paper The Evolution of the Universe?
I don't know. I don't remember anything about it other than I remember reading it, and I was struck by the fact that it had this idea that the universe had a temperature in it, and I thought, well, that's why did that disappear? Why is modern cosmology just dropped it? It's not, after that you don't see this idea that the universe has an intrinsic temperature.
Let me continue, guys, because I want to finish it. Only myself in my model, I'll calculate this temperature, measured, experimentally measured temperature of microwave background radiation with accuracy up to 4 digits after the comma. Nobody else. Everybody evaluations. I don't know how they done this evaluation, even Gamow, anybody. But only I could calculate the temperature with so good food. I'm so sorry.
Okay, so your claim
with so
is
good accuracy,
your claim is that
only myself. Show me any paper with calculations of the temperature. Nobody done. Nobody. This is
So
one
your
of the
claim is
advantages of my model.
So your claim is that your prediction is more accurate than theirs.
Not prediction, calculations based on concentration of the intergalactic plasma and all this stuff. It's the main part of my model. I have all the world filled with particles, with temperature of this intergalactic plasma and evaluation of this microwave background radiation. Not evaluation, it's calculation based on strong physical laws for black body radiation. Guys. That's
Okay.
why, don't talk about the evaluation. I calculated with a very good accuracy. Many times I refer to the paper with these measurements before my model, and accuracy I achieved with a very simple classical calculations of black body radiation based on intergalactic plasma. That's it, simple like this. That's
Well,
why
I'm
there
sure
is a
many would
temperature.
observe, with regard to your calculations, Vladimir, what they observe with regard to a lot of modern cosmology, and particularly the Einsteinian general relativity, that you've obtained these values after they were known experimentally.
Go on.
I'm just saying
Show
that
me
would be observed.
any other calculation of this temperature. Nobody done. Because there is no main idea. They don't know what does it mean black body radiation. And what is important, this spectrum corresponds to black body radiation with a very good accuracy. There is a curve and there is a theoretical calculation of this temperature based on the whole curve. You saw coincidence of the whole curve. It doesn't work this way. It's not one point. The whole curve with a temperature 2.725 degrees Kelvin based on the whole curve. That's why there is a temperature. And why there is? Because it must be some matter, intergalactic plasma. And I've done these calculations in 2013, a little bit later than it was experimentally measured once in space. It's not on the Earth. It's with satellites, you know. That's why it was very good, very accurate measurements of the whole curve. It was a detailed analysis of it. That's why, guys, I'm crying about this black body radiation for definitions. 125 years ago, it was defined already, guys, and nobody knows what does it mean black body radiation. That's why all these bullshits about spreading of the wavelengths of each photon. No, it's why? Because expansion of the space. How you can, what kind of mechanism you have to increase the wavelengths of each photons because of expansion of the space. And this is one of the main, confirmation of Big Bang model, guys. What kind
Okay,
of
let's
book
stop
we have?
here. Let's stop here and let's so the what you're saying, I find a number of things questionable about the mainstream claim. First off, they claim that there was this fireball thing, okay, a big bang, it's a fireball, and they claim that that fireball was a established a black body radiation within it. Okay, and I find that, that's kind of really, I have to say that's a leap of faith.
Oh,
I
yeah.
see that
Oh,
as a
yeah.
leap of faith. And then the issue that Vladimir is bringing up, which is they assume that space is expanding. They assume that space is expanding, and that as the space expands, the wavelength of the black body radiation created during the Big Bang, the wavelength of that radiation is increased by stretching the wavelength due to the expansion of space. That's another hypothesis that I find rather questionable. Okay. So first you have the hypothesis that there was this Big Bang explosion that created a black body effect. So you had all this matter that created a black body temperature. So you have to assume that this expanding thing was in equilibrium, which I think is questionable. Okay. And then it cools down to a point where there's this decoupling takes place. And after the decoupling, the radiation no longer interacts with matter. And so then that means that the radiation temperature is fixed at the decoupling point. And then after that, the expansion of space causes the the wavelength to increase, such that the temperature that we observe is 2.7 degrees K of this initial 10,000, 20 million, I don't know what the number is. So the initial temperature was very high, millions of degrees, and then the expansion of space caused it to appear to us to be 2.7 degrees K at our current time. And what Vladimir is saying is that that's absurd and doesn't make any sense. It makes more sense to assume that the temperature of the universe is 2.7 degrees K because it has matter in it. Is that a reasonable summary of what you're saying, Vladimir?
Summary, but what is it? It's not reasonable. It's not, and so on. It's a physics, classical physics. Don't say me reasonable. No, it's law. You have your black body radiation only if you have contact with matter with the same temperature. temperature of the wavelengths or temperature of your microwave background radiation depends on the temperature of intergalactic plasma.
Okay,
The main problem,
let me just
yes,
say here, I think the mainstream view is that the universe can't have a black body temperature because it's too diluted, and it would imply that the universe has to have an infinite age.
don't name this, Big Bang model because it's absolutely wrong. Because one of the pillars of this model is microwave background radiation. And what is important? They didn't even calculate this temperature. They assume this extension of each wavelength, spreading whatever it is, because of expansion of this space. How? What kind of mechanism? What kind of physics behind all this suspicious, proposal? And this is the main pillar for Big Bang model. Main. This is the point.
Okay, so your objection is the notion of the expansion of space, which I brought up in my presentation last week, where I said, what does this concept even mean? What does it mean for space to expand? Doesn't that imply that space is a something, that it has some kind of physical properties? How can
To the
space
notion of
expand?
space. You're absolutely right. What does it mean? What does it mean, space, guys? Temperature, I gave you the very good definition. It's a temperature known for 125 years. Please don't go around. It's a physical law. That's it. Temperature, I know it, no problems. And how to measure? You can measure with wavelengths. You have your curve, and based on this curve, you can tell what is the temperature of this radiation in conjunction with some kind of matter, intergalactic plasma. Because without intergalactic plasma, there is no wavelengths, there is no radiation, there is no black body. I'm so sorry.
But
Okay,
you went
so
further, Harry. You made a proposal, which I found interesting, that perhaps it represents the convective, may I use the term, convective temperature of the ether, so that there's a relationship between whatever particles that the ether is composed of, the velocity of those, and the temperature by the normal formula. But even though I'm an etherist, and I've looked at the properties of the ether in various respects, electromagnetically and so on, I don't think that really washes, for the reason I gave, because we're really talking about a radiation temperature, something that's received. It may be very, very difficult to isolate a thermometer bulb from radiation, but theoretically, if you could do it, I think you wouldn't get this 2.7 Kelvin.
You cannot do it, sir. Because you will have a block, immediately it will have temperature 2.7. Inside of this block, it will be temperature of this wavelength still 2.7.
Well, that's what I'm
You
asking.
cannot
I'm
block.
not sure of that at all.
No,
yeah, that's what Ian's not convinced, Vladimir.
Quantum physics, guys, please go to textbooks and read definition. What does it mean, black body radiation? Thermoequilibrium with matter. Without it, it doesn't work. And if you have
Right.
your block with 2.7 degrees K, because of
Okay,
the
okay.
outside.
You've said this before. So the key point is an equilibrium of radiation with matter. Okay, so that says that if you there has to be matter that's creating this radiation. Okay, everybody agrees to that. The issue is that mainstream claims that the matter that creates the radiation occurred during the Big Bang. The Big Bang created the matter of the Big Bang. When the Big Bang created matter and did whatever it did, it had this very high temperature. That was what created the radiation. And after that, the thermal radiation process ceased. There's no black body radiation after that. Okay. But the other alternative is, suppose the universe has a temperature of 2.7 degrees K because it has matter in it. Okay. And they assume that the universe is a void space. They don't assume there's an ether. They don't assume that the universe has material existence, and so therefore it can't have a thermal equilibrium. They're just completely
Yes,
resistant to
you're
that idea.
absolutely right. Vacuum, this is the main killer of this black body radiation. That's why they have to invent this spreading of the each wavelength of each photon and so on and so on, because there is no interaction after that. How
I
to
think they say,
decrease
I
temperature?
hesitate to speak for them because I don't accept their views, but I think they would say that yes, the temperature of space from a radiant point of view is 2.7 Kelvin because that's determined by the reception of the cosmic microwave background radiation. However, the convective temperature of outer space is undefined because there's nothing there, it's a vacuum. I think that's what they say.
No, there's no
Well, I think
vacuum,
the
and that's
idea,
it.
hold
Forget
on,
about this temperature.
They
I
may be
think this, I
contradictory.
think we're talking about words and definitions, convective temperature.
What does it mean? What do you
They,
mean convective temperature? What do you mean?
For convective temperature, you need a material
Ah, material.
whose molecules would impinge upon the bulb of the thermometer to define a convective temperature. Now, if you're in an absolute vacuum, if you could create, you can create something which is very close to a vacuum. There are no molecules there to impinge upon the bulb. So if you put this bulb into a little chamber, which is almost at a total vacuum, there's no temperature there. It's undefined. I suppose whatever the mercury, whatever level the mercury is in, when you press the temperature in, it'll remain at that. It won't get hotter, won't get colder. So that's undefined.
There is no
There's no convective
vacuum.
temperature.
You're
what
talking
they're
about
measuring,
vacuum, but there is no vacuum. That's it, simple like
Well,
this.
okay, that's the question. I'm talking about if there is.
what they're measuring is the local plasma within our galaxy. That's what they're measuring. The temper, but it's local. It's not a universal temperature.
So do you think 2.7 Kelvin is our local temperature given by this plasma? And it might differ in other parts of the universe. Rick, do
Well,
you think that?
if you remove yourself from our galaxy, you'll find that there's less matter to make temperature.
Yeah, well, again,
so that
labor the
that's
point. You're getting back to the convective temperature as distinct from the radiant temperature.
No,
which would be
black body
universal.
radiation. You need matter to excite the other matter beside it to give temperature.
No, but still what's
Okay, let
giving
me
the
give you
temperature
another point.
is the molecules impinging upon the measuring device.
Molecules or
case.
atoms.
Yeah.
Yeah.
In your case, the plasma.
I think what Ian is saying is temperature is measured by a thermometer, and what cosmologists are saying is temperature is measured by black body radiation.
Yeah, they're distinct things which are
One
given
more time.
the same name.
One more time. We are measuring temperature of intergalactic plasma. It's a medium. It's not macro objects, galaxies, and all this stuff. No. Most of our universe, in your words, my word, intergalactic plasma. We have particles like galaxies, solar systems, and all this stuff inside of this liquid ether, in your words, intergalactic plasma. It's 99% empty instead of vacuum. We have medium, cosmic medium filled with intergalactic plasma. Means if you have concentration of intergalactic plasma, all the world the same, you have the same temperature immediately. Guys, don't invent all these new galaxies, new matters, and all this stuff. It might be only some kind of fluctuations, but intergalactic plasma is all the world the same temperature, not only in our galaxy, in all the world we have the same temperature because it's based on intergalactic medium, ether, some kind of ether, or cosmic medium, in my words. That's why don't invent new definitions. Don't do it.
I thought the sun was hotter than the earth.
He's talking about the universe excluding objects like stars, galaxies, planets.
Come on,
Well,
guys,
my question is
intergalactic
how are
plasma.
you going to measure intergalactic plasma from within galactic plasma? I don't think you can. I think you have to go outside the galactic plasma to measure the intergalactic plasma.
Well, intergalactic plasma, you can measure. It is done already by fast radio bursts. It's a radio waves. You can you have some different speed of each
Okay,
wavelength.
okay.
You have some. I'm
All
sorry.
right. I'm sorry, Vladimir, you're changing the subject a bit. What you're saying is you think that there's proof that this intergalactic medium exists based on the fast radio bursts.
Yes.
Okay, so you're claiming there's proof based on the fast radio burst dispersion of the pulses that there is this intergalactic medium, that this medium does exist, and you claim there's a proof of it, and that this intergalactic medium has a temperature, and the temperature is 2.7 K. That's what you're claiming.
Yes.
Okay.
But what is important, intergalactic plasma measured by different classical physicist law. Dispersion of radio waves, no temperature, no this UV or all this stuff, radio waves. And what is important, these fast radio bursts going billions of years from the source to Earth. And most of these radio waves going through the intergalactic plasma only because particles, galaxies, and all this solar system, as I told, it's like a bronze particles moving inside of this huge cosmic medium. This, you see, confirmation of intergalactic plasma, separate, independent on all our wavelengths of our microwave background based on radio waves. And what is important, they calculated concentration of intergalactic plasma in a very good, in a good relation to my calculations. Because in this case, I calculated concentration of intergalactic plasma earlier than they opened this fast radio burst. They've done it later. It was my prediction. Guys, what is the concentration of intergalactic plasma? Oh, they measured it and they proved, they confirmed my calculations of intergalactic plasma. But if the concentration of intergalactic plasma correct, then it's a correct microwave background radiation because there is a direct connection between intergalactic plasma and microwave background radiation, what we're looking at.
Okay.
You see?
All right. Do we have any questions about Vladimir's dissertation?
So to space. No. Don't. Temperature is something different. I want to know your opinion about space, guys. The last time I tried to understand, and now the same story. Let's go with
Okay,
space.
well, I think the issue here is when you say temperature of space, Ian has a problem
Microwave
because
background radiation
Ian
of
has a
cosmic medium,
problem.
not space. It's not
Well, no,
space.
Ian has a problem with the concept temperature of space because he wants it to be measured by a thermometer. And we have the other side of the coin, which is that mainstream physics is measuring it by microwave background radiation, which they claim is the measurement is 2.7 K, but they have a different interpretation of where this 2.7 K temperature of space comes from.
And they're converting the power received, presumably, to a temperature by the Stefan-Boltzmann law, where it's proportional to the fourth power of the temperature.
Well, they claim that it's the cosmic microwave background is a relic radiation. That's where they use the word relic radiation, which means that it's proof of something that happened second or two after the Big Bang or whatever, 0.2 seconds. So that's a big cosmic fireball that has black body radiation, then then that decouples from the as space is expanding, and then we're left with this expanding radiation, and as the space expands, the radiation wavelength is stretched out.
By relative
Do they say
radiation,
that it happens to be 2.7 Kelvin now, but that it'll be a different value at a later stage, and it was a different value at a later stage because of expansion of space? Or are they saying, that it's constant value? You seem to be saying
It's going
that,
down. It's going
sorry,
down. It's not constant.
yeah.
Well, if
The mainstream would say it's going down.
yeah,
And you
because
said
if
that
the
as well.
universe is
Concentration of
expanding,
intergalactic plasma going down.
I'm not
That's it,
sure
simple as
of
this.
that. I think maybe, according to my theory, it might be constant, but I'd have to think about that.
well,
well, if the universe is expanding like they think it is, I don't think it is, but if it is, then you would expect the temperature to go down
Yeah, quite
over
so.
time.
That's what I was saying, according to their lights, which most of us would dispute.
Right.
well,
And
it's-
with the work of Halt and Arp showing that quasars that are physically attached to galaxies with different redshifts puts redshift into and the expansion of the universe into question. I mean, Halt and Arp was a student of Hubble, and he worked with Hubble and understood redshift the way Hubble figured it out. But then he found these anomalies, these quasars that are supposed to be billions of years in the background, physically attached to these galaxies that are closer than billions of years in the background, physically attached.
Well, there
And
are anomalies like that, which would indicate that the redshift can be due to various causes.
more than just one anomaly.
But
He has an
the
atlas
general
of
one,
these.
it seems to be observationally that the farther an object is away, the greater the redshift. And that can be explained, well, so I say, quite adequately by assuming that there's a property of space, call it the ether or whatever, which results in a diminution of the
Plasma has been
energy.
shown
Tired light, if you like to
slow.
call it that.
Plasma has been shown to slow the speed of light down by 5,000% in or 5,000 times in the Sapphire project. So plasma is responsible for tired light. The motion of light through plasma slows it down and stretches its wavelength.
Yeah, but when you were talking about ARP and so on, you seem to be saying, well, look, we don't know where redshift comes from. It's all over the place. I'm saying
He
there's a
calls it
general relationship.
he calls it quantized redshift, where
Yeah.
it's the redshift of an object is the property of its youth, how youthful it is, and over time, redshift lessens and lessens, and as it gets further away from the parent galaxy, its redshift goes down in numbers.
Well, that seems to be a bit of a hybrid in that, they talk about objects which are further away being earlier in time when they're talking about the creation of the universe, the Big Bang model, and so on. Whereas I'm not talking about that. I'm just saying it has a greater distance of space to traverse, and therefore, if this process you're calling it, what you call it, plasma diminution.
Tired light.
Yeah, well, we both call it tired light, which probably originates as a bit of a pejorative term as well. But I consider that.
But
as
it's the
well.
motion through the
But if you
plasma that's
didn't have
causing
that,
the
you would have
tired light.
a perpetual motion machine, which is basically against the first law of thermodynamics. You have to have some diminution. If an object which is being carried as a wave in some way or other, let's say through a medium, that has to diminish with time.
It does in our oceans.
In our oceans, yes, seismic waves and sound waves and everything else. Yeah.
Okay, we got 10 minutes.
if
So
these are
we're in broad agreement, but we have different ideas as to the exact mechanisms, I think.
Right, yes.
If these
Well,
are,
I think the issue is this idea of the universe expanding. Is that what does that mean? Mainstream is sort of latched onto the idea that space is expanding as if space is something physical. Okay, so when the
Well,
and
could
it's
could space be, or sorry, could the universe be expanding into nothing?
well, that's another issue. I just
I don't think it
I
can.
don't really I don't I've never really I always thought this expanding of space has never made sense to me. It never has made sense to me. When I first was exposed to the idea in a astronomy class when I was in college, I just thought that's just mind-boggling. It doesn't make any sense. It still
Well,
doesn't make any
that's
sense.
Hubble's work with the Doppler effect.
No, there are alternative explanations of it. They just have adopted the idea that space is expanding.
Yeah.
And Hubble considered all those possibilities. They just latched on one and said that's Hubble's explanation. It wasn't by any means. It was one thing that he said might be, but he looked at
Yeah,
time.
and then they latched onto it, like you
They
said,
latched onto it and they called it Hubble's law.
and they like it because it fits their perception of this Big Bang explosion that's slowly moving or quickly moving
You see, what they're
away
even
from
saying
the
now is
center.
they're modifying their words. I was listening to some program recently on the Sky at Night, and they were saying, "Oh, it's a pity it's called a Big Bang, and it's a pity it's called an explosion. It's neither of those. It's again the operative terms, expansion of space. So you better get out of your mind the whole idea that it was something like exploding and physical energy going out. It's not that at all. It's space which was expanding."
Which to me is a non sequitur. It's a meaningless idea. I
Well, to
mean,
me, I think
yes,
what
so. Yeah.
I mean, space, what is space? It's a nothing.
But
According to them, space is nothing. So nothing
even
is
worse, they say
expanding.
space-time is
expand
expanding.
nothing. It's a very good question. How you can expand nothing? I don't know. Harry,
Space-time is
you're
expanding.
absolutely right as usually.
Hmm.
What does it mean space, guys? Only then you can talk about expansion because it's impossible to expand nothing.
Well,
What does
that's
it mean
my thought.
space?
That was why I was completely puzzled when they told me this at my astronomy class. And I thought, well, space is nothing. How can it expand?
It cannot, logic. Guys, what
if
is your opinion about space? This is the most important question of Harry. The second session we have right now, and we cannot answer it. Please, your opinion about does it mean space for you guys? Geometry, empty space, vacuum, what is it? How it can expand? Nothing, I mean.
Well, that's, I don't know. All I know is that to say space expands puzzles me because it's kind of a meaningless thing to say because you have to know what space is in order before you can say it expands, and we don't know what space is, so it's just a meaningless to me. It's meaningless to say it.
And presumably to
Yes.
say that space is curved is also meaningless to you.
Yeah, it is. Yeah, because
Right.
I don't. You have to know what it is before you can tell me what it, how it behaves, and they can't
Yes.
tell me what it is.
Let me
And
remind you my point, very important point. You cannot introduce space, time, and gravitation without cosmic medium. There is no cosmic medium. There is no meaning for all these definitions. No time, no space, no gravitation. This is the main point. You must have something cosmic medium. Only then you can start talking about space, time, and gravity. You
so
see?
you're taking the point of, and I understand your point of view. Your point of view is that we have to be talking about something that's physically meaningful. Okay, the physically meaningful thing is cosmic medium. So you're saying that when people talk about the universe, they're really talking about a cosmic medium, something that is physically real. And to be physically real, it empty space or space, void space, the usual idea of what space is, isn't physically real. It's just a mathematical idea, philosophical idea. It's not a real thing. It's not anything.
Not really, it's a geometry only. There's the Big Bang model, all this stuff, it's a geometry only. And there
Yes,
is
it's
no
just that.
physical meaning behind of it. No
It's
meaning.
right. It's just
That's it.
geometry. That's all.
It's just
They're
geometry. That's why. That's why space. What does it mean, space? Without something, cosmic medium, you cannot start even talking about it. You cannot expansion. You cannot do anything about it.
Well, space
This
to
is the
me
main
is
point.
some type of medium where matter can exist. Like Vladimir calls it the the intergalactic medium. There has to be a medium where matter can exist.
Yes, yes. Only if you have your matter, you have your cosmic medium, only then you can start talking about space, time, and gravitation. Simple like this. And what is important in my model, there are parameters behind of them.
There's
Behind of them.
space, time, gravitation, and EM. Everybody keeps forgetting about electromagnetism.
well, I'm
That's
not
what the
forgetting
universe
about
is
it.
made of.
I'm not forgetting about it.
No,
All
don't
right.
lie.
That
As
gets
a
to
part of cosmic medium, there is so named intergalactic plasma. Simple like this. Of course, there is a matter, there is electromagnetic radiation, even transmission of these photons through intergalactic plasma. It's interaction, electromagnetic radiation of this radiation with intergalactic plasma. Only then you have your thermal equilibrium and you have your temperature. Only this way.
But space
okay.
may very well contain material, but it is a geometrical conception for what matter or what objects are existent in. If you say, "Oh, space Euclidean," well, that's a valid question. If you
Geometry,
say, "What coordinate system should you use?" I mean, we were talking the other
geometry.
week about
There
Cartesian
are no
coordinates,
coordinates.
where you
No,
are
wrong.
where
There is no
you use it's
coordinate
a natural
system.
Cartesian system to use this coordinate from three different walls, from a ceiling and from two walls. But you could just as easily use a polar coordinate system, which would be just as valid.
Time check, Terry.
I think we're running out.
We've got 2 minutes, so we're coming up to the end. Yes, I talked about this. Cosmology can have different geometries of space. So their method is they assume a geometry and see if the measurements agree with their geometry. The problem is there are so many different geometries and so many ad hocs that you can put into the model of your geometry that it's kind of, in my mind, a hopeless task to figure out what the geometry of space is by the method they're using. Okay, I got 1 minute and 24 seconds. I guess I'll thank Jim for presenting. Interesting talk.
Thank you.
We'll learn a little bit more about AI. Let's see, we need the presentation for next Sunday. And we could suggest topics, or we can continue talking about what is space. This seems to be a topic that we can talk about for a very, very long time.
Please continue.
Did
In
you
temperature.
talk to Ito about the subatomic model yet?
No, I haven't. I haven't talked to him about that.
Well, he's going to give a talk.
He received your email, and
He's giving a talk to a Saturday session. I've arranged that with him.
yes,
You know
I understand that, but I was trying to set one up for the Sunday sessions.
All right.
All right. I'll see. I'll send out a inquiry tomorrow about requests for presentations. Okay, I want to thank everybody for participating in our discussions today. We got a little bit raucous